We are up for a crazy Atlantic hurricane season. It may be even worse than that of 2005, the year that brought us Hurricane Katrina. That one took 1,392 lives and cost the country over $100 billion. Experts predict there will be between 17 to 25 total named storms. Some of these storms are about to become hurricanes, with winds reaching over 100 miles per hour or higher. We're already seeing storms sweep across the country, bringing dangers like tornadoes, flooding, and hail. You gotta thank the El Niño Southern Oscillation, or ENSO, for this. This complicated term has to do with El Niño and La Niña, the two giant forces that basically shape our world. Normally, winds in the Pacific Ocean blow west along the equator, moving warm water from South America towards Asia. This warm water is replaced by cold water rising from the depths of the Pacific. But during El Niño and La Niña, this usual pattern is messed up. El Niño is the warm phase of the ENSO cycle. During El Niño, the equatorial winds weaken, causing warm water to shift back towards the west coast of the Americas. This means less cold water rises to the surface. The weather in northern parts of the US and Canada become drier and warmer because of it. But there are wetter conditions in southern states. In the Atlantic, El Niño weakens hurricane seasons, and it ramps up hurricane activity in the central and eastern Pacific. In Africa, it brings more rain to East Africa but less to southern Africa, West Africa, and parts of the Sahara. La Niña is the cold phase of the ENSO cycle. During this phase, the westward winds along the equator in the Pacific are stronger than usual, and they push more warm water towards Asia. And because of it, colder, nutrient-rich water rises to the surface along the Americas' west coast. These colder Pacific waters push the jet stream northward, giving us drier weather in the southern US, but wetter and colder conditions in the Pacific Northwest and Canada. La Niña also brings warmer winters to the southern US and cooler than normal temperatures to the north. La Niña usually calms hurricane activity in the Pacific, but intensifies it in the Atlantic. In 2023, El Niño was in charge, and it took most storms up before they got to the US. But this year, we've switched to La Niña, and this lady brings us colder water in the Pacific and a pattern that lets storms move a little farther west and reach the Caribbean. And when they get there, they can easily move into the Gulf and affect Florida and other states. The upcoming intense Atlantic hurricane season also has to do with a strong monsoon season in West Africa. It creates moisture and waves off Africa's coast and can travel along the Atlantic and spur hurricanes. The Atlantic hurricane season runs from the 1st of June to the 30th of November, and most activity happens between mid-August and mid-October. Since the 1950s, tropical cyclones have been given names to make it easier for meteorologists to inform the public about them. You're more likely to remember that Leslie is coming than Hurricane X34D is on the way, right? So there are 20 names on the alphabetical list this year, from Alberto to Beryl to Valerie and William. Let's hope it won't get as terrible as the Galveston hurricane. The most fatal natural disaster in U.S. history hit Texas in the year 1900. A Category 4 hurricane smashed into Galveston, demolishing over 3,600 buildings with winds over 135 miles per hour. It took the lives of between 6,000 and 12,000 people. One of the reasons it became so fatal was poor communication policy. Days before the disaster, it was clear to a professional weather forecaster that the storm was moving west. But the Weather Bureau in Washington predicted it would go over Florida and up to New England, which was way off. The Bureau was just 10 years old then, so hurricane science in the US wasn't very advanced. Cuban scientists were excellent at tracking storms because their region is so prone to them. So they knew it was heading towards the Gulf of Mexico. Unfortunately, the director of the Weather Bureau was so jealous that the Cuban forecasters were better than the American ones that he cut off the flow of information from Cuba and made it difficult for local forecasters to issue warnings without going through Washington. In the days before the storm hit, the chief observer in Galveston began to suspect that Washington's forecast was wrong and tried to warn the city, but it was too late. The hurricane left Galveston in ruins. After this hurricane, the Weather Bureau started improving communication both internationally and within the U.S. The officials in charge are doing everything possible to improve forecasts, support the people, and help the affected areas recover more easily after the hurricanes hit. They're going to try new forecast models to predict tropical cyclones getting stronger, help emergency and water managers prepare for potential flooding, and protect people and infrastructure. Coastal weather buoys in the tropical western Atlantic and Caribbean have been upgraded, and new drifters and sail drones, underwater gliders, and a lightweight drop sonde will provide real-time data. There are also some things you can do to ensure your safety before, during, and after a hurricane. If you live in a hurricane-prone area, Florida, Georgia, and the Carolinas, you must always be prepared before the high storm season. Make up a family disaster plan that will outline your actions during an emergency. Map out several evacuation routes in case your primary one is blocked, and decide on a meeting place if you get separated. You can arrange drills to teach family members how to shut off water, gas, and electricity, and even make sure the youngest knows how to call emergency services. Pack a disaster kit that will be ready to go at a moment's notice. It should include essentials like food, water, a first aid kit, and flashlights to last at least 72 hours on your own. You can buy a generator to make sure you have electricity in case of a power outage until the power returns. Keep it in a secure place, away from rain and rising water, with proper ventilation. You're also going to need self-powered radios and flashlights. If you can, add a safe room to your house that's strengthened to withstand high winds with reinforced concrete ceiling, floor, and walls. Make sure you have enough canned and non-perishable food and bottled water for at least 3 days. When the storm is about to hit, head north to get away from it, where it will be much weaker by the time it gets there. It's much safer to keep your family and pets together away from the storm than trying to ride it out at home. Try to go in one car if possible. Always follow local evacuation orders, especially if you're in a mobile home. Fill up your gas tank and give yourself plenty of time to get out. Never leave your pets behind. Debris, floodwaters, or flying objects can be dangerous for them. If you're staying put during a storm, you need a safe spot for you, your family, and your pets. This place shouldn't have any windows or skylights. If you're hiding at home, close all interior doors and secure the exterior ones. Quickly find an interior room with strong walls and no windows, like a bathroom or closet. If your home isn't safe, look for a community shelter. Get to your shelter at least 2 hours before the storm hits so it doesn't catch you outside. Bring a battery-powered radio with extra batteries for updates every 15 to 30 minutes. Never leave your shelter even if it seems calm, as conditions can get worse quickly, especially if you're in the eye of the storm. For extra protection, lie on the floor under something sturdy like a table. Don't use electric appliances, phones, or showers during the storm. Don't leave your shelter until you get the official all clear from the authorities. Be careful. There will be many hazards outside.
Hurricanes can be a lot scarier than we often realize, especially since they can actually trigger earthquakes. This surprising and frightening phenomenon, known as stormquakes, was discovered completely by accident not too long ago. It started with scientists trying to find out more about low-frequency earthquakes. We're talking about those earthquakes that are so weak that we can't actually feel the tremor. See, beneath our feet, the Earth is constantly vibrating in subtle, unceasing ways that we can't hear or see without the right equipment. This geologic hum, so to speak, is driven by the movement of oceans, which covers about 70% of our planet's surface. Scientists have found that this hum may actually provide useful records of environmental happenings. To figure out where it's coming from, experts use equipment known as seismometers. You can think of these devices as little ears pressed to the ground. They can pick up all sorts of vibrations, like fans jumping up and down at their idol's concert, airplanes flying by, or even super distant earthquakes shaking the ground. Very low-frequency earthquakes are hard to track over long distances because the signals they produce can look different on different measuring devices. To solve this problem, experts came up with a way to track these signals by combining readings from smaller areas, kind of like putting together a puzzle. But while doing this, they stumbled upon a strange set of events that looked a bit like the earthquakes they were studying, but were not exactly the same. The first weird thing they noticed was that this specific phenomenon was seasonal. It never happened between May and August, for example. That is completely different from earthquakes, which can pretty much happen any time of the year. The second strange thing is that earthquakes usually occur more in the western part of the United States, where the ground moves along cracks in the surface. But these new strange vibrations spread not just along the west coast of North America, but also over to the east side. So what could be triggering this new phenomenon? What they surprisingly discovered is that many of these tremors coincided with the same time that massive storms hit North America. So we are essentially talking about a chain reaction. What happens is that during a specific season, hurricanes or heavy storms can transfer energy into the oceans, creating very strong waves. These waves then interact with the solid Earth, producing intense seismic activity. These bursts of energy that are born from massive storms can radiate thousands of miles across continents, leading to what we now call stormquakes. It is believed that this phenomenon can trigger earthquakes at a magnitude of up to 3.5 on the Richter scale. This means it can be felt by many people, but normally doesn't cause any damage. But that doesn't mean we can all be relaxed now, as ocean waters can indeed increase the intensity of hurricanes, just like what happened with the frightening Hurricane Milton, which recently left a path of destruction across Florida. The blue-purplish zone you're looking at is Hurricane Milton, seen from a satellite perspective. On October 9th, this hurricane sustained winds of 155 miles per hour and lashed the region with heavy rainfall, damaging winds, and life-threatening storm surges. Estimates show that the losses could be up to $34 billion, which could make it one of the costliest storms in United States history. What happened with Hurricane Milton was pretty tricky. It all started with some record hot water in the Gulf of Mexico. That warm water acted like a power-up, giving this hurricane the energy it needed to grow. And then, there was also this process called eye wall replacement that helped it get bigger too. We'll get to that in a moment. So as Hurricane Milton approached the coast, something unusual happened. It crossed paths with a fast-moving air current called the jet stream, which flows high up in the atmosphere. Now normally, the winds in the northern and northwest parts of a hurricane are not as strong as those in other areas. But because of this interaction with the jet stream, the winds in these parts of the storm became much stronger than expected. At nearly every turn, Hurricane Milton surprised everyone and intensified faster than we have seen in ages. It threatened to slam both Florida's west and east coasts with a dangerous surge of water, putting the bustling area of Tampa Bay, which is home to over 3 million people, at serious risk. So how did Milton become such a major problem? Well, the problem started in the eastern Pacific Ocean. Usually, hurricanes follow a fairly predictable path, spinning off of Africa's coast, sailing across the Atlantic, and gaining strength in the warm Caribbean waters. But Milton had a twist in its origin story. It began as the remnants of a tropical depression that crossed over the Yucatan Peninsula and met a stalled front in the Gulf. Once Milton got going, it didn't hold back. But when it hit those record-high ocean temperatures, it was like giving it an energy drink. The warm water and humid air were the perfect ingredients for a hurricane on the rise. Quickly, Milton's wind speeds increased by 92 miles per hour. So it went from a tropical storm to a Category 5 hurricane in less than 2 days, which is basically insane and off the charts. And if that wasn't enough, Hurricane Milton also went through this thing called eye wall replacement. Now, hurricanes spin around a mostly clear eye in the center. But overnight, Milton started forming new bands of rain on its outer edges, creating a second ring around its eye. This process helped Milton grow even bigger, spreading out the wind speeds and giving it a larger footprint. It's kind of like shedding its skin and getting ready to become even more powerful. Hurricane Milton also had this little wobble in its path, which changed where it was heading. You can think of it like a spinning top that gets nudged and wobbles a bit before finding its balance again. That wobble meant some areas could get either hit hard or be spared from the worst of the storm. Thankfully, Hurricane Milton weakened a bit because of some tricky wind changes up in the atmosphere until it finally made landfall. After that, it moved across the peninsula and headed out to sea, quickly losing strength as it pulled away from the warmer waters. Now, even though the damage was significant, the good news, if you can call it that, is that experts were honestly expecting things to be way worse. Still, it raises a question. How close was Milton's wind speed to the maximum? Or, in other words, is there a limit to how strong a hurricane can get? Well, the answer is yes, there is a speed limit for hurricane winds, but it's not a set number. Right now, the strongest the storm can get is around 200 miles per hour. But that maximum speed can change depending on many factors, like the heat in the ocean. Think of the ocean as the fuel for hurricanes. The warmer the water, the more fuel these storms have to work with. Experts believe that as the oceans continue to warm, they can ramp up the wind speeds and the impacts of hurricanes, making them a lot stronger. But other things can also help figure out how intense a hurricane can get. For example, the heat in the air and the temperature at the top of the clouds matter, as they also affect how fast heat moves from the ocean surface to the top of the storm. Some estimates suggest that maximum wind speeds could reach closer to 220 miles per hour until the end of the century. So it's definitely something that experts need to keep an eye on to help prevent future disasters. As we move forward, it's essential to keep researching and studying these storms. The more we understand them, the better we can protect ourselves and our communities.
Oh, gosh. Wow! Whoa! All right, buddy. No time to think. Whoa! Let's try to survive. Wow! I gotta move as fast as I can! It's already here! Ugh. Everything's falling apart! Ooh. Yeah, I hope this way works! Let's go! Wow! Let's go this way! Hey! I didn't break a single bone. Okay now, what's next? Oh no, not ready to give up yet! No worries. There's a main road behind these houses. Let's try to get there. Get into the car! Hurry up, babe!
We need to get out of here. Now!
Let's go! Whoa! Did you see that? Oh, watch out!
Ah! Look out! We need to get to a safe space.
Don't panic. We'll get out of here. Look! This is it! Hold on!
Ah! Whoa! Here we go!
chance to swim away.
Whoa! Can't believe we did it!
Congratulations, you're saved. Thankfully, it's just a simulation and no one got hurt.
Come on, let's get out of here. No! No! It can't be! It's a tsunami! Whoa! Hold on tight! We need to go faster! Whoa! It's catching us! We have to get to the land! Look out! It's too late! Brace yourself! This is going to be a bumpy ride! Keep going! We're back in the city? Whoa! Oh no. Okay, we need to get off this boat. Whoa, that was crazy. Be careful, it's slippery. Go on that roof. Ah! Oh, you saved me. I thought I was a goner. We can move along that fence. Go! There's no time to waste! Oh no. We need to get onto that building. We're almost there. Get to the top of the tower. Look, there's a helicopter. That's our ticket out of here. We're safe at last. I can't believe it.
Whoa! Ah! Whoa, that was close, huh? Gotta keep going! Wah! Let's go!
What are we gonna do now? Oh no!
No! Made it! Phew! Wow! He can't help us, Ava. We have to navigate this boat on our own.
Whoa, it's so shaky.
This weather is too stormy for a cruise. Watch your head, babe!
Look,
No time to panic. Let's get out of here.
ouch.
Ava, are you okay?
No worries. I'm all right.
Grab something and hold on tight. You can be washed away by a wave.
Okay. Look out.
Wow. This city is a hot mess.
Careful. Maybe we could try to get on a roof.
Yeah. It's not safe to stay on board. Are you ready?
Yeah.
See this building? We need to get inside.
Ava, where are you? Can you hear me?
Hey, wait for me. Everything's falling apart. It feels a little dizzy. Okay, let's try this way.
Oh, there you are.
Phew, I'm so glad you're okay.
Nice view, huh?
Whoa! Have you ever seen anything like this? No! We need to get out of here. Now! Look out! Ah! Come on! We need to get to a safe space. What are we going to do? Ah! We need to go now! We need to hurry up. Please! We have to get out of here! We need to get out of here. Here we go. We made it.
It was June 1928 when Mr. Keller almost lost his life in a terrifying natural disaster. He was outside with his family when he noticed an umbrella-shaped cloud that seemed to be approaching them. It gave him a sense of foreboding. A tornado was probably forming there. Indeed, in no time, 3 huge funnel clouds were dashing their way. After rushing his family into the storm cellar, Keller decided to have another look. And what he saw both terrified and mesmerized him. The twister was directly overhead, but inside the swirling cloud, everything was eerily still. The man could feel a strong, grassy smell. He had trouble breathing. He looked up and saw a circular opening right overhead. It was around 50 to 100 feet across and around half a mile high. Keller could clearly see the walls of the rotating cloud. Constant bursts of lightning zigzagged from side to side non-stop, illuminating this horror movie scene. The man could also see many smaller tornadoes forming and breaking free. A deafening, hissing noise was overwhelming. And the next moment, the tornado skipped over Keller's house and smashed the home of his neighbors. Mr. Keller wasn't the only person to see the tornado from the inside and live to tell the tale. But other survivors didn't end up as unscathed. It seemed to be a regular day when Chris Tuving from Dallas, Texas got to the Little Caesars in 2019. They had run out of pizzas, so he decided to wait. Well, it was a grave mistake. A powerful tornado hit the shopping mall where he was staying and pulled him out of the building. Chris managed to find a support column and held on for dear life. But no muscle strength could compare to the terrifying power of the tornado. Tuving was lifted into the air and thrown into a truck parked in front of the restaurant. He tried to hold on to the hood, but there was nothing to grab. In the end, he managed to hold on to the rim of the left front tire and stayed there until the whole nightmare stopped. The tornado Chris survived had sustained winds of 140 miles per hour and was 13 football fields wide at the base. Eric Simmons recalled taking cover from a tornado in May 2019 by climbing into his truck. Once inside, he looked out of his right windshield and saw vines growing along the fence. They were moving around in a bizarre way that confused the man. And then it all started. Suddenly, everything Eric could see was wind and pitch-black darkness. Then, a section of a roof flew over him and shredded apart mid-air. The truck's back windshield shattered, showering the man with shards of glass. A tree in front of him was lifted into the air like a twig, and the fence blew over the top of the truck. Simmons could feel the back of the vehicle lifting. He could see the power lines exploding right in front of his eyes. Even though the visibility was terrible, he could still see the flashes. It all lasted around 45 seconds, but to him, an eternity seemed to have passed. When the coast grew clear, Eric got out of the car, but he could barely walk after the shock he had lived through. He couldn't speak. It was one of the most horrifying and traumatic experiences of his life. According to the man, the real reason why he was so terrified was because he had no training, no warning, and no defense against whatever was coming. Later, he found out that the tornado had almost taken his life at a speed of 86 to 110 miles per hour and was around 75 to 100 yards across. A tornado is a rotating column of air that touches the ground. Sometimes it's connected to the base of a thunderstorm. The wind speeds inside tornadoes can top hundreds of miles an hour. No wonder they have enormously devastating potential, picking up objects, unrooting trees, destroying buildings, you name it. The problem with escaping a tornado is that it's not always easy to see. The wind, however severe it is invisible. The first sign of an approaching tornado might be the infamous rumble resembling the noise a moving freight train produces. There are also some other sounds indicating that a tornado is coming, but the human ear can't perceive those. When you spot that classic tornado cone, it means it has already developed a condensation funnel made of water, dust, and debris. The most destructive tornadoes are born from rotating thunderstorms, called supercells. Luckily, those are something meteorologists can actually notice because such storms have a well-defined appearance on radars. Experts believe that the difference in the temperature of such a storm can determine how likely a tornado is to form. And still, there's a lot we don't know about this process. For example, the question about why and where tornadoes are most likely to appear remains unanswered. The strength of tornadoes is measured with the enhanced Fujita scale. The rating goes from 0 to 5, considering the damage caused by a tornado and its wind speeds, where EF0 is the weakest tornado and EF5 is a tornado I hope you will never ever come across. The EF scale rounds off at wind speeds of 318 miles per hour, with strong frame houses being lifted off foundations and carried long distances to be eventually broken into pieces. Cars fly through the air for more than 328 feet away, and steel-reinforced structures are left badly damaged. Despite this terrifying power and ferocity of tornadoes, authorities report that even the worst of them have a 99% survival rate. but it doesn't mean that you shouldn't take all possible precautions to avoid ending up inside one. Stay away from doors and windows. Move to an interior room if possible, and use pillows, blankets, and mattresses to protect yourself from flying debris. If stranded outside during a tornado, crawl into a ditch and cover yourself, protecting the head. Now there's another twister that is as scary as a tornado, but this one forms in the water. Whirlpools appear when fast-flowing water crashes into an obstacle or another current. The water starts swirling in a downward spiral, creating a vortex that can pull objects, animals, and even small boats that happen to be nearby to the bottom. One more way for a whirlpool to form is the sudden appearance of a sinkhole created by a collapsed cave, for example. This makes water flood the hollow structure and creates a whirlpool similar to the one you see when you pull the plug out of a bath filled with water. While some whirlpools are small and brief, others can reach enormous sizes and be driven by constant currents. The most dangerous of them are maelstroms. If you get into a whirlpool like that, your chances to get back to the surface are slim. The incessant movement of the water and its pulling power can leave you disoriented and stuck without air. That's what happened to Stuart Foulstone when he got trapped in a whirlpool. His first instinct was to swim out of it, but this idea proved to be hopeless. The footage filmed by the cameraman attached to his helmet later showed that the man had been underwater for almost 3.5 minutes. He had probably been dragged all the way down to the riverbed. There, the pull of the twister lessened a bit and finally released its hold. The guy was lucky to get spotted face down in the water and pulled to the surface by a kayaker. The depth a whirlpool can pull you down to can vary. It depends on its power and size. Sadly, not everyone who got trapped in a whirlpool survived and got out again. In different ways in which whirlpools form means that sometimes they can appear out of the blue. You can't predict this process and get no warning. So the best way to stay safe is to wear your life jacket at all times when in the water. If you get pulled into a whirlpool, try not to move in the same direction as the water flow. Aim for the outer edge rather than the center of the twister. If you're lucky, the whirlpool might throw you back up. There have been precedents. And if you come over a whirlpool in a boat or kayak, do your best to stop the boat from filling with water. If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
June 29th, 1764, seemed like a regular day in one small picturesque town in Germany, Waldeck. Residents were in church. Little did they know that a powerful storm was about to hit the area. It wasn't just an ordinary storm. It was a strong, swirling tornado getting closer and closer. It was an F2 tornado at the beginning, strong enough to uproot trees like oaks and beeches. But as time went by, it grew and became more powerful. It even picked up 2 children on its way and threw them into a lake. Something strange happened too. The water level in the lake rose and then quickly retreated. Leaving the lake behind, the tornado struck a house, tearing off the roof and knocking down the walls. Then the tornado changed direction and headed east-northeast, increasing its intensity to F3 level. That's when something fascinating happened. A possible twin or satellite waterspout merged with the tornado along the shore of Lake Luzin. It was like 2 tornadoes coming together. It got wider and stronger, so it started snapping and uprooting solitary oak trees, flinging them 115 feet into the air. It left behind a barren landscape, removing crops, grass, and even topsoil. Back then, people couldn't even read or write very well, let alone use devices that could predict a tornado. This one was so strong it destroyed houses, barns, and even uprooted trees. Such a terrifying thing to see. But there was something special about the church people were in. It had strong stone walls, so they were safe inside, even though everything outside was getting destroyed. They didn't even realize how lucky they were until later. With winds estimated to be over 300 mph, it was unstoppable. The tornado traveled a distance of 19 miles and stretched to a maximum width of 0.6 miles. A raging storm threw tree branches so high, people believed they ended up in the atmosphere. Another strange thing about this tornado was that it occurred during a dry storm. There was very little rain reported, but the storm still managed to make such a mess. It even produced large hailstones, some as big as 5.9 inches in diameter. Just imagine chunks of ice that large falling from the sky. These hailstones caused significant damage to crops and properties, and everything else that was outside at that time. After the storm passed, one scientist, Gottlob Burchard Gensmer, studied the damage and talked to people who had witnessed the tornado, only to realize this was one of the strongest tornadoes ever recorded in history. It reached F5, the highest rating on what's called the Fujita scale, which measures tornado strength. It took an hour for the madness to stop. Back in 1925, people in northeast Missouri didn't have an organized tornado warning system either. It took them by surprise when one day, in the early afternoon, they saw a tornado forming in that area. At first, it was a small one that briefly lifted off the ground. But as time went by, it started growing into a massive monster. Meanwhile, in West Frankfort, Illinois, some miners were working deep underground, about 500 feet below the surface. Suddenly, the power went out, and they knew something was wrong. They quickly started climbing up the shaft to get to the surface. When they finally made it, they were in for a terrible shock because of the devastating consequences of this giant tornado. The tornado didn't even stop there. It kept on making a mess as it traveled a long distance. It plowed through the land for a whopping 219 miles, all the way from near Redford, Missouri to the east of Princeton, Indiana. It moved at a crazy speed of 73 miles an hour. In one town, Murfreesboro, Illinois, the tornado wiped out a staggering 100 blocks of the town, plus another 70 blocks ended up destroyed by fire. In another town, Griffin, Indiana, not a single building was left standing. The tornado got weaker only at 4:30 in the afternoon. This tornado, known as the Tri-State Tornado, really made history as the worst and longest-lasting tornado ever recorded in the United States. In April 1965, people in the region of the Great Lakes started complaining about this weird heat. The forecast showed no storms for that area. It was because of thunderstorms sweeping across the upper Midwest of the United States. These storms were insane and so powerful they created 51 tornadoes in just 12 hours. The states of Indiana, Ohio, and Michigan ended up being hit particularly hard. Something unfortunate happened during this time. All this caught the forecast team, the National Severe Storms Forecast Center in Kansas City, Missouri, off guard. They quickly tried to send out warnings to let people know what was happening, but many people didn't hear the announcements because there were no outdoor tornado sirens at that time. Additionally, a lot of TV and radio stations didn't regularly broadcast weather alerts. Power was gone, and telephone lines didn't work, which meant many towns were completely cut off from communications. People couldn't receive the warnings because they didn't have access to electricity or working phones. One spring day in 1974 was especially hard because of severe thunderstorms that unleashed a series of powerful tornadoes across 13 states in the United States. These tornadoes lasted for 16 hours, and they ranged from weaker F0 to the most powerful and destructive F5 ones. At one terrifying moment, there were 15 tornadoes touching the ground at the same time. One lasted for more than 2 hours, and 2 others were swirling around each other like dancers. This was another big lesson, after which some changes in tornado warnings were made. In those days, weather forecasters could only warn people about a tornado if they had seen one with their own eyes, which was mostly too late. April 26, 1989, at around 6:30 in the afternoon, the sky above one district, Maniganj in Bangladesh, turned dark and ominous. The tornado began its journey from one point, Daulatpur, and moved swiftly eastward, Saturia, Maniganj Sadar. People living in that region had already been facing a severe drought, and little did they know there were even worse scenarios coming. The storm was fierce, stretching about 10 miles long and 1 mile wide. It covered a relatively small area, but it still caused enormous damage. It tore through the land and blew away buildings, thousands of trees, strong and rooted for years, and everything else in its path. The countryside of Marsala in western Sicily is really beautiful. But it wasn't so stunning on December 8th, 1851. 2 fierce tornadoes suddenly swept across the land, leaving nothing but chaos. As they moved, they brought along heavy rain and hailstorms, causing even more damage to the already vulnerable farmlands. One town, Castellammare, had an amazing harbor with plenty of ships, and it suffered great damage. The news of this devastating event reached far and wide, even making its way to the Illustrated London News. The outbreak in Oklahoma from 24 years ago, May 3rd, 1999, was tough too. Just one stormy day caused enormous damage from Texas all the way up to South Dakota. At least 45 tornadoes touched down, and Oklahoma was hit the hardest with an F5 tornado. The story seemed familiar. What first seemed like a small twister quickly grew into a massive force that, at one point, measured 1 mile in width. This one ripped asphalt from roads, peeling it away in layers like fragile paper. It tore the vegetation away and even wrapped roofing materials around power lines. NASA scientists studied the area using satellites. They realized it would take between 10 to 20 years for the vegetation to fully regrow in the region where the tornado left nothing but muddy, barren land. Oklahoma is in a pretty unfortunate spot when it comes to tornadoes. Take 1947 as an example. The Woodward tornado got named after the city it had struck. This monstrous tornado was massive. It reached 1.8 miles in width, and it raced forward at an incredible speed of around 50 mph. Before reaching Woodward, the tornado had already caused a lot of mess in other towns along its path. But it was in Woodward where it unleashed its worst fury. Without any warning, it struck the city at 8:42 in the evening, catching the residents by surprise. Communication with the outside world was cut off, leaving families uncertain about the fate of their loved ones. As if one tornado isn't enough, some areas get struck by a series of them. In 1908, an outbreak of tornadoes swept across the eastern part of the United States, from Texas to Georgia and then northward from Oklahoma to Tennessee. At least 34 tornadoes touched down. Nature showed no mercy. Buildings were torn apart, and once thriving streets were reduced to rubble. The Fujita scale measures tornado strength based on two things: the speed of the winds and the amount of destruction caused. F5 tornadoes are the strongest, most destructive ones. I mean, some people talk about F6 tornado with winds that could blow at over 300 miles per hour. If this one was passing by, you'd definitely know how Dorothy felt. Luckily, F6 exists only in stories, and Oz is the last place you are likely to end up at.
Check this out. There's a giant tornado heading towards you, and it's so fast. These twisters can move at crazy speeds of more than 250 miles per hour. Plus, they can carve a pathway 50 miles long and a mile wide. Sometimes you can see them coming clearly, while in some cases, low-hanging clouds or rain can hide them, so they sneak up on you and you don't even see them. And in most cases, a tornado can develop so fast that no one can even warn you in time if it's already too close. And now, this insane storm is really close. Maybe you have a couple of minutes to get somewhere safe. Do you have a basement? Go hide. Or maybe, I know this is a crazy idea, but what do you think about going inside a tornado to check what it would be like? Now, some tornadoes appear as rope-like swirls, while others have wide clouds in the shape of a funnel. And here's the second one, right before you. Look at these whirling winds born in a thunderstorm. They extend down from it to the ground. Many times, hail joins the party too. The U.S. itself has something like 1,000 tornadoes per year. Texas holds the record with about 120 tornadoes per year, a record not to be proud of. But you'll generally see most twisters in Tornado Alley, which is a stretch of land in the midwestern part of the U.S. They develop when warm, moist air coming from Mexico meets cool, dry air from Canada. These two clash and turn into a powerful storm that at some point can spawn tornadoes. And you'll see most tornadoes there between April and June, though lately some have come even in December. They can range from a regular dust storm to an incredibly powerful force that can carry away cars, large trees, and even houses. But this is a unique chance. You've never been this close, right? Plus, it's a gigantic one. You don't often get to see such a big one. Okay, ready then? It's getting closer. You feel the wind getting stronger while tossing dirt and debris in your face. You close your eyes and whoosh, you're inside, and it's crazy. Vicious winds are hurling and spinning you around. They're lifting you up at the same time. Feeling dizzy? Feeling like Dorothy from The Wizard of Oz? Now may be a good time to check what's really happening to you, while inside swirling with winds and, oh wait, is that your neighbor's motorcycle spinning together with you? Hope it'll stay that far away. Now, let's take a moment to catch up. Being in the middle of a raging tornado is actually something you might survive. But I won't lie to you, it won't be easy. The first thing you'd sense would likely be the temperature changes. Inside this crazy twister, it can be 36 degrees colder than outside of it. That's because the center of the tornado funnel spins all the time. All that funneling makes the inside of the vortex way colder, and it makes the air way thinner than you used to. The air would be 20% less dense than, for example, what you would find at high altitudes. Now, I hope you're not planning to stay there for too long. Disclaimer here, the atmospheric pressure inside this swirling vortex is so low that your lungs won't be able to extract enough oxygen. Now, to give you a perspective of all this, breathing inside a tornado is like trying to get some air at an altitude of 26,000 feet. That's a pro level, similar to climbing Everest. So yeah, you'll need some help just to be able to take a regular breath. In short, you'll probably pass out after only a couple of minutes. But don't worry, I brought you this special mask. so breathing is not a problem anymore. Hey, did you notice how smooth the airflow from the inside is? Some storm watchers ended up inside a tornado. Later, they said it all looked so chaotic with all those raging clouds and wind swirling around. But from the inside, the air is surprisingly smooth. But that doesn't mean you'll get a peaceful ride because of it. And it's not a solo party in that thing. The neighbor's motorcycle is not the only thing you'll see there. Wood, bricks, glass, maybe even cars, cows, motorhomes, bricks, roofs, and other big objects. You'd be pretty lucky if nothing crashes into you in all that chaos. With all that debris that's swirling at, for instance, 310 miles per hour, you can hardly avoid it. But let's just say a miracle happens and you got through it. Now you're really dizzy, and you're just wondering when all of this is going to be over and if you're even going to be able to come out of this gigantic tornado. Well, the tornado will eventually slow down. It happens because cool air enters the twister. Just because things are settling down, it doesn't mean you can relax. Well, your stomach can, since all that crazy swirling is done, but the tornado will drop you from whatever height you're on when it stops. If you're somewhere in the countryside, there might be some soft bale of hay to break your fall. Oh wait, we're talking about a twister that's probably more than 45,000 feet tall, so that won't work. I hope you brought your parachute, because now would be a good time to pop it. Nope. Hey, don't worry. I'm all about happy endings, so I'll help you out. Here you go. And now you're slowing down, enjoying the view, if you even see anything around you from all that dizziness. How come there are clear sunlit skies from your left, you may wonder? It's not unusual. Tornadoes often form near the edge of a thunderstorm. It's like a border between two different worlds. And it wasn't even windy. Plus the air was very still before it hit, right? Well, that's common too. Okay, I think you know this kind of scenario is impossible in reality. So it would be best to find a safe spot quickly if a tornado is close by. Use your underground shelter first. And if you don't have one, your basement could be the next best choice. Prepare ahead of time with a battery-operated TV or radio, together with fresh batteries, or a device with internet to be able to hear the latest updates on the tornado. Include some non-perishable food, water, and other essentials prepared too. As it turns out, some people really were picked up by tornadoes, and they managed to go through it. A tornado actually dropped them a few hundred feet away without a scratch. Hey, I'd say that's a whole lot of bother just to save some bucks on Uber. But you can't have a guarantee you'll be safe or where you'll end up. It would be incredibly hard to get out of one of those big and fierce ones, though, like supercells. They fall into the category of the strongest type of storms, mostly thunderstorms. And imagine falling into waterspouts. Those could be fine, though, at least the beginning, because they're weak and they form over warm water. So they could be like a part of your spa day, at least until they move inland and turn into a real tornado. Now, dust devils wouldn't be that pleasant. They're not that big, but we're talking about columns of air that rotate at large speeds. And you can easily see them because of all that dirt and dust they pick up, which is why you need glasses for that. Whoops, wait, I forgot that, so I can't help you this time. But if it makes you feel any better, they're not associated with thunderstorms. Don't know why that would make anyone feel better when I think about it. But if you're willing to jump into a fire tornado, I'll find you a special suit that will keep you safe while spinning through smoke, gas, and flames. I promise. Columns here are narrow and they rise vertically into the air, similar to a dust devil. Of course, the heat is crazy. And as updrafts are becoming stronger, and if there's enough dry fuel, a fire whirl is turning into a real fire tornado that extends from the ground up to the cloud, moving incredibly fast. Okay, let's stop now. I'm pretty dizzy.
The ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, Crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat as you peer through the window at the sudden chaos outside. You're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth. You always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water. It's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, the crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over ½ an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy. The Sahara. Nope. It's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching, sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, They noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, The quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific, and 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, Make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet, 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?